Welcome back to the show. My name is Chili and I done fucked up again. So let's see what I did this time. Why don't you try opening up our little thrust solution here. Set it to debug. Because I didn't actually build it last time. I gave you the tour, but I didn't build it. So I'm going to clean the fucker. Build that fucker. So we build it. And it builds fine, as expected. Let's try building the release. Cleaner and builder. And we get a nice fat linker error. Mismatch detected for runtime library. We have dynamic and we have static. Here's our problem. And it's basically boils down to the fact that you can individually set your code generation settings for these CPP files. So some of them are set for, let's just see if I can get it open here for you. Code generation. Some of them are set to multi-threaded, and other ones, if I can look at this one, are set to multi-threaded DLL. So we've got dynamic linking, we've got static linking, all mixed up, fucking up your shit. So what we're gonna do, ladies and gentlemen, is gonna close this bullshit. Actually, I'm just gonna close this whole fucker thing. I'm gonna take this thrust thing here, I'm gonna throw it in my recycle bin. Say, fuck you, man. You're going down. And what I want you guys to do is go on the website where you found the template, and I want you to download the new template, the Chili DirectX framework, March 31st version. And so we'll rename our bullshit again. Engine thrust, create directory, add source control. Now with 50% less linker errors. Delicious. Okay, so again, same deal. Nothing has changed, except that now when we go release and we go build solution, succeeded. We have success. You should also notice that the build might have went a lot faster for you this time, and that's because I enabled multi-threaded compiling. So it's going to use multiple cores to compile different files. So all in all, good times were had. Alright, so that ends this installment of Chili Done Fucked It Up. Now on to the actual lesson. And today's lesson, I was going to make today's lesson about rotation and stuff, but that would actually end up having me just like write out a lot of math for about an hour. And I figured since last lesson I didn't really code anything, I just talked at you for an hour. Maybe if I did that again, I might have a revolt on my hands, a revolt, an uprising, an insurgency. I can't speak today. Insurgency. Yes. So I decided we'll change things up for a little bit. We'll do a little actual programming in this programming tutorial today. How does that sound to you guys? Sounds good. Okay. So, I didn't really explain it in that depth, but the kind of graphics that we're going to start off with in our game here is going to be kind of vector graphics using just lines, right? So we're going to need some data types to help us out with that. So let's see here. We'll get our project up in here. Now the kinds of things we're going to be working with is a poly, I call this a, what do I call it? Let's add a new item. Header file, and I call it a polyclosed because it is a closed polyline. So what do I mean by a closed polyline? Well, let's get our diagramming magic on. Let's get our diagramming on. So let's go with red today. So let's say you've got a set or a list, an ordered list of vertices. Here is vertex 0, 1, 2, and 3. All right. So a polyline is just a line that connects all of these vertices. So it goes from 0 to 1. Oops. That was dumb. It goes 0 to 1, 1 to 2, and 2 to 3. Right. Now let me fix my stupidness here. Let's get rid of that. It should be 0. Let's do that. 0, 1, 2, and 3. Something wrong with my fucking thing here. Okay, here we go. So again, polyline 0 to 1. Did I do it again? Oh god. My brain has just shut off here today. I blame it on the end. It's the end of the day, you know. I had a long day. So 0 to 1, 1 to 2, 2 to 3. Now a closed polyline also adds another line segment from the last vertex to the first vertex. Right. When you have a polygon, the points on the polygon, which are connected by lines, those points, we call them vertices. So this is a vertex, this is another vertex, etc. And of course our vertices will be represented, this is our x and our y, they will be represented by vectors, right? Because we're doing everything in vectors. It's going to be vector style from now on. Everything's coming up, Millhouse. So, yeah, we want to make a class that represents this. It's basically going to be a list of vectors, right? And those that will define the vertices for our closed polyline. And we're going to call that motherfucker polyclosed, which I did right here. So, let's get on with it. Polyclosed. Pragma wants class. Closed. Okay, very simple. Now, our class is going to be just a list of vectors. So we're going to need include vec2. And we're going to need include vector. Now, obviously these two things are different. This is a mathematical vector, a two-dimensional mathematical vector. This vector is a container, and it's basically just a dynamically resizable array. We're all adults. We understand these things, don't we? So, let's go private. And what do I want? Well, I want a STD. I want my STDs. I like them dirty. And I want a vector of vec2s. Actually, I'm going to make them constant vec2s. Because I don't want you to be able to change the vertices after you've created your vector. And I'm going to make the vector constant too. So once you create this motherfucker, you can't add any new vertices to it. And we'll call this one a vertices. Because that is what it is. Let's add one more file here. # include colors. Because I like colors. They're pretty. They're pretty. We'll put D3D color and color. So our polyclosed will have a color and a list of vertices, or a list of vectors which define its vertices. Okay, and burp, and let's create a constructor. Polyclosed. So how are we going to construct this motherfucker? We are going to use new fandangled C++11 technology here, people. We're going to use what's called an STD, initializer list. This is a new thing that came in with C++11. It's an initializer list. What should I call my list? Vertices, maybe? Yeah, I'll call it that. And the initializer list is a template. You have to tell it what kind of list it is. And it's going to be a list of vectors. Why don't you like it? Identify. Oh, okay, it's just lag. It's just lag kicking in there. And we want a D3D color. Color is equal to white, because that's a nice general color. Okay, so we have initializer list. Now initializer list is basically just a special kind of vector, I would say. It's basically just a special kind of dynamic array that's supported by the language. It has better support from the base language. And one thing we can do with initializer list is all the standard containers take initializer lists to initialize them. So we can do this. We can just go vertices. I'm going to call this list. I'm going to call this one vlist. List of vertices and vlist. So we can just pass this initializer list directly onto our container, and it will initialize the container in one shot. And color is going to be color. There we go. That is our constructor all set up. Next on the menu is we're going to need a function to draw this motherfucker. So we're going to go, what are we going to do? We'll go void draw. Make it constant because it's not changing anything in the thing. And we're going to need let's go vec2 position. So that's the position at which we want to draw this thing. And D3D okay. Gonna need our graphics here. D3D graphics. Okay. D3D graphics and GFX. There we go. Okay, so now we've got to basically loop through each one of these vertices and draw a line between it and the next one. So we're going to use iterators here. So here's what we could do. We could do something like for std vector constant vec2 constant iterator I is equal to what is it equal to? Vertices dot begin. There's one thing we could do, but we're not going to do that because we have special magic for C++11, and that magic is called auto. My name is Otto and I love to get blotto. I think I made that joke before. Whatever. The idea here is that this function knows what it's returning. It's returning a what is it returning here? it is returning a constant iterator for a vector of constant vec2s, right? So that is known Khaleesi. So what you can do is if you specify your variable as auto, the compiler will try to guess what type you want, and it will automatically define your variable as that type. So in this case, it can sense the type because it knows what this function returns. And in those cases, you can use auto. And using auto is really good because look at this compared to this. Which one do you want to type? And I mean, all this bullshit just kind of clogs your code up. Make it auto. Problem solved. And we also want end is equal to vertices dot end. So this will get iterators pointing to the beginning, which is the first item in the vector, and end, which points to the position after the last item. It doesn't point to the very last item. It points to the item after the last item. Next, we want to do our test, which is as long as I is not equal to the end. And as long as that is true, we want to increment our what's it called? Iterator. Increment our iterator. Yes, we do. And now, for every one of these elements in our container, we want to draw. So we go gfx dot draw line, and then we give her a mother. We give her vectors. So what you want is, what do you want? You want I. Now I by itself is just the iterator. So you use the dereferencer to get the the actual object itself. It works a lot like pointers, actually. Iterators were designed to have the same syntax as pointers. So you use this thing to get at the object. And then we want to draw to I plus 1. Here's another similarity with pointers. You can do pointer arithmetic to get, like, for example, the next element. So I plus 1 points to the next element. And the color is just color. How do you like that? You don't like it. Why not? Well, because if you look here, argument types are const vec2, const vec2. But drawLine, let's put one here. DrawLine wants a reference to a vec2. Not compatible. So, what we're going to do is we're going to open up our framework here. We'll go to d3dgraphics.h. We look at drawLine here. And we're just going to make it pass by value instead of pass by reference. Normally with objects, with classes, I tend to pass by reference because it's you only have to pass a single pointer then. Passing by reference is basically the same as passing by pointer. So if you have an object and maybe its size is like 32 bytes, you can pass it by reference, and then you're only using 8 bytes. In 64-bit operating systems, in 64-bit code, your pointers are going to be 8 bytes, right? So it's faster, but in the case of a vector, we only have 8 bytes altogether, 2 floats. So it doesn't make sense to pass by reference, so I'm just going to pass by value. Although I might make functions that pass by reference every now and then, just as a bad habit. In general, pass by value if you're not going to be saving on the speed or anything. Alright, so we draw a line from the current object to the next object. And then we're done. And yeah, that's it. This obviously is not going to work But can you see why it's not going to work? That's the question. Let's try and, well, let's build it. Although I guess this doesn't matter. It's not included anywhere. It's not going to be included in the build. Let's go to game.h. And let us, well, first let's include our new fandangled class, which is called polyclosed. And let's add a polyclosed here. We'll call it model, because it is the model. And here we need to initialize it, so we go model. Now here we have to pass it an initializer list of vectors. So initializer lists are curly brace lists. And we want a list of vectors. We can also initialize our vectors with curly braces. So I'll just go like this. And I want to make a triangle. So what I'm going to do is, let's get another pretty color here. Let's undo this. We'll get a pretty color. So I want a triangle that's like this, this, and this, right? Pretty triangle. So we'll say that this one is going to be x0, y 80. This one is going to be y negative 80, right? Because this is negative. This one is going to be x 80, y 80. This is going to be x negative 80, y 80. So here's our three vertices for our beautiful triangle. So what was that again? I've already forgotten. 0.0f, negative 80.0f. So there's one vertex out of the way. Vertex number 2. Vertex number 2 is 80, 80. And vertex number 3 is going to be negative 80, positive 80. So there are our three vertices. And we don't need to specify the color because we have a default color of white. So let me just put some space in there. So there, we can initialize our model using this initializer list. Very simple, very clean. I like it. Now we want to draw the model, so we'll go into compose frame. And we'll go model.draw. And we need to pass it a position. So we'll use an initializer list for that too. Because we can initialize the like if a function is a pass by value, we can initialize that value with an initializer list. So we want to draw this one at the middle of the screen. So we'll draw it at 400, 300. And we want to draw it with our graphics object. And there we go. Simple as pie. Nothing can go wrong. There's no way this will fail. Failed. Assertion failed. So, first of all, expression y greater than 0, greater than or equal to 0 failed. So that means we were drawing off the screen. Now, why is that? Why are we drawing off the screen? We made sure to put this motherfucker in the middle of the screen, and now it didn't draw off the screen. Of course, the reason we're drawing off the screen is because we took this position value, but we didn't do anything with it. So what we're going to do is we're going to add position to each of these vectors. See how, look at how nicely that works. With x and y's, you'd have to have separate lines and add it all up. Here, just fucking add your position vector to your vertex vector, and you're all done. You're all set, ready to go to the races. Build that solution. Debug assertion failed. This time we got a different one though. Vector iterator not dereferenceable. Dereferenceable. Yeah. Break. So here we've got a problem. And yeah, one thing I forgot. I lost my my whatchamacallit. Other windows. I lost my debugging like watch window. And I'm not sure where to get it back from. Debug. Man, it's not in here, is it? Why does that window always disappear on me? Bookmark solution team, object, browser, class view. That's not it. Error list, that's not it. Output, task list. Why is the fucking watch not in here? Like, don't you think that would be something that's kind of important? No. Okay, so unfortunately, whoever designed this, maybe I'm being dumb, but I'm gonna blame it all on whoever made this interface. They fucked up. But it doesn't matter because I already know what the problem is here, and maybe you do too. Fucking bastard. I'll fix it later. I'll get that watch back later. For now, we know the problem, and the problem is we're looping through all of our vertices, right? We're not incrementing, iterating. We're iterating through them. So we start with this one. We draw a line from. Let's just go change my colors here for a second. So we start with this one, and we draw a line from it to the next one. Then we increment our iterator. Now we're here, and we draw a line from here to the next one. Now we're here, we draw a line from here to the next one. Except, no, that's not what happens, right? Because it doesn't automatically wrap around, right? This is 0, this is 1, this is 2. The next place to go is to 3. 3, which is nothing, undefined. There is no 3. You can't draw a line there. And the debug version of our vector kindly tells us that you're trying to do something that is retarded. So, we can't go all the way to the end. We have to go to the end minus 1. Right? And then at the very end, we go like this. We go graphics.drawLine, and we go vertices dot back, which is back is the last item plus position, and then we go vertices dot front. Front is the first item, and again color. So in this loop, we draw all the lines from the first one to the last one. And then in this last one here, we draw the line from the last one to the first one. And then we have our closed polygon. And everyone is happy, theoretically. Except me, I'm not happy because I don't have my fucking debug watch. Fucking all those good debugging variable watch windows. Fuck. Alright, let's start debugging. And here we go. We've got our triangle. Is that not a beautiful triangle or what? Yep. It is triangular. We have triangulated and we are done. Oops, I made my shit go away. So yeah, triangle, good stuff. Now the next question is, this is all fine and good, right? We can make our triangles. But if we wanted to make something more complicated, like let's say we wanted to make a vector graphic of a ship, a spaceship, it's going to be pretty fucking hard to do it all typing in, you know, vectors into the text editor. That's not really the way to go. Now, what we would really want is we would want to be able to use a some kind of application that would let us create our line art, and then we could somehow use that line art in our game. That's generally how we do things in 3D, right? We create a character model in Maya or some other dumb program, and then we export it to a file, and then we load that file in our game. And so that's what we want to do with our little vector art thing. The question is, we got to choose a program, and we've got to choose a file format. And also, we got to drink water because we're thirsty. So, excuse me while I go grab some water. Good old H2O. Okay. Where was I talking? Oh yeah. So first thing we need to do is we need to decide on a program. The main thing about the program is it needs to have the features yeah, I spelled that right, that we want to create our model, right? And I looked at a bunch of programs. Actually, to be honest with you, at first I found a neat file format in one of the projects of someone from the forum, and it was I think it was .obj. I think it was an object file, but it was just a plain text file, and it had vertices kind of like this. It would be like 4.5, comma 6.2. And I was thinking, man, that's sweet. That is something that I could definitely get behind. It's super easy to load. I could write my own loader, and it'd be all set. But when I looked at the programs for the object file, I think one of them was like WinGS or something, Wings, or I don't know what you call it. And some other shit. It was all 3D, and there was no good support for just creating a simple 2D line art option. And I could have fudged it. I could have made like let's say I want a triangle, right? Just a 2D triangle. I could have made like a 3D prism, and then just just used these vertices and discarded these ones here. I said, fuck you, fuck you, fuck you. And I could have used that. I could have fudged it. But I thought to myself, there's got to be a better way. Now, back in my my youth, my misspent youth, I had a kind of part-time job after school, doing a little bit of drafting in AutoCAD. So I thought, what about DXF? What about the DXF file format? It's really nice. It's basically it's mainly, I think it started off as 2D, based on kind of vector graphics. And it's very widely supported, I assumed. So I knew that the main program that used DXF was AutoCAD. So I looked for a freeware version, open source, of AutoCAD, and I found one. I'm going to show it to you right here. It's called LibreCAD, and it basically let me do what I want, which is I wanted to create polylines. And here I can create polylines to my... Oh, well, that was dumb. Let's undo that. I can create polylines to my heart's content here. Good times were had by all. I can snap onto endpoint here, and line done. Game over. So, I found my software. and I had my preferred file format. Except when I actually looked at the file format, I figured it's open source, it's human readable, it's in ASCII. So how bad could it be? And it was kind of bad. It looked like this. And I was like, I don't want to learn how to open. I mean, I know my data is probably in here somewhere, but that looks like a pain in the ass to try to parse this thing. So I looked at on the internet for a couple minutes about the file format, and I decided I do not want to write my own parser. So then I did the thing that I should have done in the first place, which was I should have looked for DXF library C++. Because if I did that first, I would have come across good old DXF lib from QCAD, Ribbonsoft, whatever. And is an open source C++ library. Open source means free as long as I keep it open. And it lets me parse DXF files. It also lets me write DXF files, which I do not care to do. So fuck that. So I've got an idea here. I've got my DXF library. I've got my my software that I want to use, LibreCAD. The next step is to try to see if I can build the DXF library. Generally, these kind of open source libraries and whatever, they come with a little test project or makefile or whatever, and you can. The first thing you want to do is try to get that built. So this is actually the DXF library tar ball or whatever. So I'm going to extract it. I'll put this on the website too for the downloads for lesson 2, but I'll put it in a zip so that all Windows people can download it, because I know some people might have trouble with the tar. I don't know. So we'll extract this mother and see what we got. What's in the hood? And we got, I wanted to say something before I move on here. So when you're looking to have a workflow of getting a model or something into your game, you look at the program. Things like, does it have the features that I need to be able to create the thing I want to create, and how much is it going to cost me, right? Now the other thing you want to look at is the file format. Like I said, file format. You want to look at things like, you've got options, right? You can try to make your own loading format, or you can try to make a plugin for the software, for the program, that will export the data into your preferred file format, which could be some format that you already have a loader for or a library for. You can make a plugin. There's also other options like you can make or find a converter to convert from one file type to another, a separate program. So you've got all sorts of things. If it's an open source program, you don't even need to use a plugin. You can just edit the source. Although if a plugin framework exists, it's usually easier to do plugin than to try to, wade deep into all the nitty-gritties of your open source program there. So that was one thing I just wanted to point out. Now, the next step we got to take is we've got to try to build this DXF lib stuff. So we got test here and we got source. Test has all of our test stuff, obviously, and source, this contains the actual library. This is all the source files for the library, and these are just the simple test project to demonstrate the usage of the library. So this is all using makefiles and weird GNU stuff that is not going to work too well. I mean, I think you might be able to import this stuff into Visual Studio. Maybe not express, maybe yes, maybe no, maybe rain, maybe snow. But what we're going to do is we're just going to create a new project. And we'll make it a console application. We'll call it DXF test. Right here. We'll do application settings, console application. And I know it's a console because if I look at the source here, or if I look at the test, if I go to main, let's just scroll down here. Ugh, where is it? Where are you? Int main, argc, argv, and test reading, test writing, and we've got things like cout. So it looks like this is probably going to be a console application. So I create a console thing, empty project, no precompiled header. Finish him. And then I want to copy, I want to find my project folder. Where is it? DXF test. Here it is. And I want to find out where does my other one go? DXF lib. I want this one. I hope this is inside the recording window. We'll go to source. Where's DXF test? Here it is. We'll copy this source into here. We'll go to test. We'll copy in the source files and the DXF files. Forget the make files. We don't need that bullshit. And go back here. Wait. Seem to have closed my other one in the process. Whatever. Now we want to add. Let's see. I'm going to leave this here. I'm going to leave this here for you guys. Because I'm nice. I'm a giver. We'll go to DXF test. We will select all the source files. We will not select any of the other bullshit. And we'll drag it and drop it onto the DXF test project. And it will sort it into CPP and H files for us. And then I guess we want to build this mother. So we go build. And we hope that it builds without any errors. I mean, it did. It doesn't like string copy very much. It says everything's unsafe. But hey, it's an unsafe world, man. So now we're going to run this mother. And we see it quits automatically. So what we want to do is we want to add a little stopper in there. So we'll go include conio.h. That's console input output. It gives us a nice little function in here called underscore kb hit. KB hit. And what that does is it just it returns, let me think here. It returns true if it returns false if the keyboard is not pressed. It returns true if the keyboard has been pressed. There we go. I managed my way around that sentence. Let's try it again. And it still exited automatically. Why? Can you see why? Well, it's because this here. This main takes command line arguments, which are the things that you type after the, if you ever run a program in a, what do you call it? In a console window, a terminal window, I don't know what you want to call it, command, right? If you go like this and you go CMD, you get this console window, and you run a program. You run program, and everything you type after the program name, like my Sharona. I don't know if you spelled that. I don't know what it is. Blech. Well, my mouth just turned to mush there. But you get the idea. Everything you type after the program is the command line arguments. So those command line arguments get passed to your program like this. Int argc tells you the number of arguments, and char double pointer to argv is it's basically an array of strings. So it's an array of pointers to characters. Whew, there we go. So, oh yeah, and another thing is that the program name counts as one of the arguments. So that's already one. So this thing here checks to see if argc is less than 2. Because if it's less than 2, then it means that we did not pass an argument to the function. And in that case, we just return immediately. So what we need is an argument. And that argument is going to be argv. Yeah. Doesn't say in here, but it's going to be the name of the file that we want to open for reading. So we need to give it a file name. So first let's look at DXF test. So we got demo.dxf, we got 3D face, and we got my file. Now I don't trust any of these files because I don't know what they are. So I don't know if I want something simple. So I'm going to take my own file, shipd. You guys can download the DXF files for this lesson together with DXFlib, though that'll all be just together in the same place. So download the chili DXF files. I made them special for you. And let's try to open that up. So that was shipd.dxf. So we'll go to project. Let's make sure I'm over here. Properties. Now I believe it's going to be under debugging. Command arguments. Here are the arguments to pass to the application. So we'll go for all configurations and we'll go shipd.dxf. And that will be passed to our application here. We'll build again. Oh, it doesn't matter because we didn't change anything. And we'll run it. And now we get output. And how output it is. So this is what this test program is doing. It's basically parsing the DXF file and then outputting it as just a bunch of text describing what was in the file. So we see here we get a polyline, which is the thing that I made in the file. And then we get the vertices that make up the polyline. So we got the X, the Y, and the Z, and other dumb bullshit that we don't care about. All we care about really is the X and the Y. And we got that. So now we've managed to build the test solution, test project. We've verified that it works. Now we need to figure out how it works. Well, the first thing I might do is we see test reading. That's the function that reads shit in. And so we look at test reading and we see, okay, here's what's happening. We create something called a test creation class. We create a DLDXF, and then we call DLDXF in with the file name and the creation class. So somehow this in function is doing all the work, but it takes a creation class and the file name. And after that, it's all done. That's the whole thing of the function. So the magic happens in our DXF in. But before we look at that, let's look at the other files in the test function. Right, everything that starts with a DL underscore is part of the library. So let's look at the stuff that's only part of the test project. And besides main, we have this creation class, and that was used to load in our DXF. So it's got to be important. So let's look at it. So we look at creation class and we see it inherits from a class in the library. And it basically overrides a bunch of virtual functions. So let's see what it does. We'll go to the implementation here. And we see that if we go down to our good old friend vertex, because that's the one we know, here is where the shit gets printed out. So we can see that these overloaded functions, they expose a method for us to handle when the parser comes across a certain entity in the DXF file. So we can decide what we want to do whenever we come across a vertex or a polyline or whatever. And this, my friends, is the key to the whole shebang, as they say. So let me just show you one thing. DXF lib documentation. Let's look at the documentation for the DXF lib. Programmer's Guide 2. Unix. There's the building. Alright, implementing the creation interface. So this just tells you how to do the creation interface shit. And what else? What else do we got? Creating a writer object. This is for writing, so we don't even care about that. We only care about reading. So yeah, here's all your documentation right here. And it tells you what to do. But we could have inferred that just by looking at the file here. And that's actually what I did. I just looked at the source code and figured out how it works. Now the question is, can we get it to work in our own solution? Water. So good. So what we're going to do, we're going to close this now, because I think we're basically, we'll leave it open. We'll leave it open. But we're going to look at DXF test. And we're going to look at hope I didn't fuck anything up here. Please tell me I didn't misname something. Thrust. Here it is. Thrust. Okay, good. Our good friend, Mr. Thrust. We'll go to our engine here. And we're going to copy over all of the whatchamacallits. The library files. That's what I want. That's the word I was looking for. But we're not just going to copy them directly into this folder, because that is just going to be a whole bunch of bullshit that I don't want to deal with in my folder. We're going to organize shit, because Chili is nothing if not organized. So we'll go new folder DXF lib. Right. Then we're going to copy, mind you, don't just move it, copy it over. Copy all of our DXF lib stuff into here. Alright, now we want to open up Thrust. So we'll go back here, open up our Thrust solution, and now we want to copy our shit from, where's engine? Here we go. From here, select all, drag that into our engine, and realign my window here so that you guys can see what I'm doing. Good. And you see, look at all this dumb bullshit in here. I don't want all this DXF stuff messing up my folders, but I don't want to put it in framework either. So we'll add a new filter. We'll call it DXF lib. And we'll select all these ones, put them in there. Minimize that. And we'll do the same here for the source files. We'll go add new filter, DXF lib. And we'll add these guys in here. Add this one in there too. Give them a home. Give these little guys a little home. That's it. Just pull them up. Okay, now don't want to open this one. Now comes the moment of truth. I want to get it so that I can load my poly closed with that other bullshit. Now to do that, I'm going to create a new class, because remember, I have to inherit from what was it? Let's go back to DXF test for a second. I've got to inherit from, oh my, DL creation adapter. So I've got to inherit from this. So copy that. Go back to our good old friend here. I'm going to go class poly closed loader. Inherits a public DL creation adapter. Change the style a little bit because this is my style. We're in flavor country now. Ugh. Too many colons. Okay, so first thing we want to do is we want to include the stuff that we need for this DL shit. So we go include, and we go to DXF LIB, and we go creation adapter. And that fixes that problem. Now we go back to, no, not this one, to our test project here, and we're going to copy and paste add vertex. We don't care about add polyline because we assume that the DXF file that we're loading only has a single polyline, and all we're interested in is the vertexes that compose that line. So we add this, and I'm going to add something C++11 on the end here. Override. I don't know if I explained this before, but override, what that does is that makes sure what we say we want to override a pre-existing virtual function. So if we mistype something or fuck something up, it will tell us. It will say that doesn't exist, so you're overriding nothing. So it's just it's optional, but I think we should use it whenever we can. And that's really all we want. We just want to add the vertex. Now the question is, what do we do when we add that vertex? Well, we go private. Now we want a vector of vertices, but we don't want it to be constant because we have to continually add new vertices as they're being parsed. So we can't make it constant. So we'll make that just a non-constant vector of constant vectors. And now comes the very simple magic. All we got to do is, well, let's look at what it does in the sample project. So we'll go to test creation class.cpp. We'll scroll down too far. The vertex, and all it does is it uses data.x, data.y, data.z. So this data reference to a data class that we're passed, we just use it. Use it. So we'll go vertices dot push back, and that just adds a new vertex to the end of the list. And we want to push back a new vertex, so we'll use the initializer here, and we want data.x, data.y. Now I don't like that, and the reason is because data x and y are doubles, and we want floats. Our initializer needs floats. So we go float, and that should solve this problem, which it does. And there you go. So that's the only thing we need in our loader, I think, the vertex. But we're not finished yet. Let's go back to our test project. demonstration here. So in order to load the DXF file, it creates the creation class. It creates a DXF class here, and then it uses dxf.in to load the file. And it uses the creation class to handle all the things that it's loading in. So we need a dl.dxf. Now we could do this all externally like they do here. They have a creation class and then they create the DXF outside of the creation class. But we can make this all wrapped into one neat bundle, all encapsulated and beautiful, by putting that shit in our constructor here. So what we're going to do is we're going to go poly closed loader, and we'll do std string file name. So we'll take the name of the file, and here we're gonna go. First thing we're gonna do is we need to include something. We need to include dl_dxf. Okay, that makes sense. So we'll go up here, # include dxf lib dl_dxf. In here, create dl_d. Yeah, that one. That's the one we want. Call it dxf. And what else? What else do we need to do? I think then we just call dxf pointer to, wait, it's not a pointer, dot in, and we use the file name, and we use the creation interface, creation adapter, right, which is just this. It's just the current object, and that works fine, no problem. And once we call in, then DXF will call add vertex, which will push vertices back into here. Now we need a way of getting the vertices out, and we'll do that with what should we do? Let's try standard vector constant and get vertices constant return vertices. So this will just return a constant reference to our vertices, and then we can use that reference to copy. So here's what we're going to do. Down here we create another constructor, polyclosed. This time we take std string file name, and again with the color defaulting to white. And now for our actual initializer, we go vertices, and we create a new polyclosed loader. We create it with the file name, and we go dot get vertices, and that will get us our constant reference, and then the copy constructor will copy them into our vertices here. And of course we'll new color. Wait, that's wrong. That doesn't make any sense. Also, we need a comma here. We color again. And there you go. Now we have our second constructor, which constructs from a file. So we can construct from a direct list of vec2s, and we can construct from a DXF file. Yep, I know what you're thinking. Chili has done it again, that sexy bastard. But there's going to be a few bumps in the road still. Not quite so many, but a little bit. let's just see if we can construct this mother. So, we construct with, what was the name? Let me just go back here. Ship D, my file. Odd. Let's go to thrust. Shit, did I close it? Where is it? Where's engine? Ah, it's not there. Okay, we go to thrust. We go engine. Do we have any DXF files in here? No, we do not. So we want ship D in here. And I guess we want... I'll put this back in the DXF test. And I'll put ship try. Like I said, these two DXF files will be available for download on my website. So we'll try ship D. We'll see what that looks like. So ship D.dxf. And that should be it. Build it. Build's fine. Although I would like to do something about all of these warnings. Maybe I'll fix that later. Let's try to run this mother. Unhandled exception, stack overflow. Yeah. So there's a problem here. And you could try to debug your way out of the problem. But I'm going to save, if you want, you can try. I would applaud your efforts. But I'm going to save you the trouble and just cut to the chase. What is the problem here? The problem, it seems, is right here. It's actually here. In this line here. Well, no. Because this line works fine. It's in this line here. Where is it? This line right here. dl.dxf. The act of creating this object actually basically just blows your stack's butthole right out. Super prolapse. I don't think it says anything here about it. But you basically have to create it on the stack because it's just a huge object. And that's before you load the file. It's just creating the object on the stack is enough to blow your stack's butthole right out. And that explains something strange, which is this. Like, why would you just create it new if you're just going to delete it afterwards? Like, why not just create automatically on the stack? And the answer is, it's too big to fit on the stack. So we have to create on the heap. Now we could create it on the heap like this. We could go, pointer to DXF is equal to new DXF. But we can do a better job using some C++11 shit. And that C++11 shit is called unique pointer. Smart pointers, basically. Now, smart pointers are smart because they manage their own memory. It's an object, and the pointer itself is created on the stack, right? So we create a smart pointer. We call it unique pointer. Here it is. And it's templated, so we template it to dl.dxf, right? And we'll call the pointer pdxf. And we initialize it with a new dl_dxf. Like this. And that gives us our unique pointer. And then here, we just go pdxf pointer to in, and that's it, we're done. Because this unique pointer object, when it leaves the scope, when the scope leaves whatever, when the scope passes the object by, the destructor for this one will automatically call delete on this memory, and it frees up your memory. You don't have to remember about it. There's other things to do. There's different kinds of smart pointers. There's a shared pointer, there's a weak pointer. They all have their uses, and I'll probably be going over them. But here's one of the simpler usages for a smart pointer, and it's like this. Now we can do another thing here. This is fine, but there's a more recommended way of creating smart pointers, and it's basically this. PDXF is equal to, and then we go std make unique. It's a function, and it's templated, and you go DL_DXF, and you put in your function calling brackets here, and I think, yeah, that's fine. And for some reason, this can sometimes be faster than calling new. I don't know all the internals, but sometimes it works better. So they recommend that you use make unique instead of doing new. And if you do make unique here, because the return value is set, you can do auto here. So you don't actually have to do much extra typing. You do auto PDXF is equal to make unique DLDXF, and you're set. So that's just one thing I wanted to introduce to you guys. Smart pointers. We'll be seeing them later on as I find new uses for them. But here's one place where you actually could use them. Normally you wouldn't create an object like this on the heap, you'd create it on the stack, but it's just so fucking huge, you got no choice. So I use auto pointer and everybody's happy. Everybody happy. Let's build solution. All right. Now, let's see if this works. And it works. Here is our beautiful ship D. Don't you love it? I made it special for you. It's interesting though, because I modeled this upwards, right? But it's pointing down, because in the original modeling program here, in this program, Y increases in the up direction, whereas on the screen, Y increases in the down direction. So if you want to fix that, what you can do is you can go where? You go into this loader here, you go add vertex, and you just make this negative. So you invert all the Y coordinates. And if I build that, run it, now it's pointing upwards the way that nature intended. Delightful. So, yeah. So there is our vector art loaded and drawn. Now I've got this weird error thing. Expression failed. Debug engine. I'm not sure why this is happening. I'll look into it and I'll probably get back to you guys later. But for now, I can make that homework. Figure out why it is fucking up when we close the motherfucker. But that's not the thing I wanted to talk to you about. There's one extra C++11 thing we can implement here. It's not a big deal, but it could be a big deal in other situations. And that is when we use the polyclosed loader, we fill up a vector with all the vertices, and then we copy all those vertices into this vector here. So, you know, we've got our vector, and we fill it up with stuff. And then we've got all this. This is all allocated on the heap, right? And then we've got another vector. And we also allocate memory on the heap for this one. And then we copy. We read the values of these and copy them into here. And then we delete this one. Now, doesn't that seem like a big waste? Wouldn't it be better if instead of creating new memory on the heap, copying and then deleting this one, if we just made this one's pointer own this data, and this vector would no longer own it, so this vector would now be dataless, basically just moving this data from this vector to here. And you weren't really able to do that before. But from C++11 you have something called move semantics. And let's see here. You guys are going to have to look at this. You can look this up on your own later. But there's a whole new set of... Actually, they extended the language itself, the core of the language, to be able to do this move bullshit. And let's see here. C++11 move... See, look, move semantics. We're going to use move with... containers. C++11 move from container. I just want to see some decent code. This code does not look like what I want to do. Right, so we get an efficiency boost concerning containers with std move, some expensive type, pushback move. Ah, interesting. That's not what I'm looking for though, although that is something interesting you could do. Let's try move vector. How to use move semantics to bring moving all elements of a vector. Here's what we want. So this dude is saying that he's got a vector A, he's got a vector B, he's copying B into A and then clearing B. And he doesn't want to do that. He just wants to move all of B into A. And this guy just says A is equal to std move B. This is how you do it. So let's try that in our bullshit here. We're going to go down here, not in the list, down here, get vertices. And we're going to go std move from these vertices into these vertices. And try to build that, see if it works. And it did work. And still works here. So you won't notice a difference, and it's not a big deal here because we're only loading once. It's a very small performance improvement. But you should be aware of this, because if you're using vectors and you're in a sort of performance critical situation, this could actually speed you up quite a bit. Or it might allow you to use code which is more robust and just better, instead of having to make more hackneyed code because you don't want to take a speed hit of copying vectors. So yeah, move, it's a thing, it's a new thing, it's shiny, and I like shiny. I like it a lot. Why is this thing doing dumb shit over here? Did I mess something up? Build. Nope, I didn't mess anything up. It's just fucking with me. It's just that old C++ fucking with me again. Seriously, why is that still underlined? Now I'm getting pissed off. But I don't know. All I know is... Okay, I'm going to try it one more time. I'm going to clear... Okay, it disappeared. Phew. I swear that in IntelliSense, it fucks with me sometimes. I think it's aware of me. It has become sentient and is now just fucking with me whenever it can. So yeah, here's our poly closed, and here's our loader. We managed to import a whole other library into our project and made it coexist with our code. I think you should feel accomplished. For me, because I did it. You just watched. So, you get nothing. But I hope it was a good experience for you. And next time, when we come back... Oh, wait, I'll show you one more thing. When we come back, we're going to do sexy times with rotation. We're going to spin it. But I just want to show you the less interesting ship that I made. I'm not sure which design we're going to use for the final game, this one or the other one. I'm still on the fence, but I'll include both of them in the downloads, and I'll include the DXF LIB, DXF library, and I will include the corrected, updated version of the solution template. And your mission is to figure out why this thing is exiting with a code 3 and going bah and pissing, just making weird noises. Figure that out and tell me, because I want to know. I'm an inquiring mind, and if you guys figure it out for me, then that's one less thing I gotta do, because I'm lazy. So yeah, that's it. Before I continue to waffle on, I'm going to say adios.